All right, in this section, we're going to talk about section 7-4, dealing with percents. And in this section, we'll look at how to recognize fractions, decimals, and percents as representations of rational numbers with conversions from one form to another. And then we'll use proportional relationships to solve percent problems. Also, we'll apply techniques to solve problems including discounts, interest, compound interest, and percent increase and percent decrease. And also we'll apply strategies for percent mental computation and estimation. Okay, so we're going to look at what percents are. There are special kind of fractions, namely fractions with a denominator of 100. And the word percent comes from the Latin phrase percentum, which means per 100 or per 100. And of course, there's a definition. Well, in percent is going to be that number n divided by 100, because the word percent means per 100. Okay. And because n percent equals n over 100, one way to convert a number to a percent is to write it as a fraction with a denominator of 100, and then the numerator gives the amount of the percent. Okay, but there are ways of converting percents to decimals. Decimals to a percent. One way that I would do that would be to take the decimal, move the decimal point 2 places to the right, or you can take the decimal or the fraction and multiply it by 100. Okay, because of course, percent, you have to be dealing with 100. So that means we can multiply by 100, which we will do in this first example. Here we're going to express each of the following as a percent. Like in part A, we got 2.47. I'll do this over here, 2.47. And I want to convert that to a percent. Well, a good way to do that would be to take 2.47, multiply that by 100, and then we'll add the percent sign. Multiplying by 100 is the same as moving the decimal point 2 places to the right. So 2.47 times 100, we move the decimal point 2 places to the right. That puts the decimal point behind the 7. So it'd be 247. And then we add the percent sign. So 2.47 as a percent would be 247%. All right, part B, 190.8. And I'm going to convert that to a percent. Well, with this, we can still multiply by 100. And multiplying by 100 means we move this decimal point 2 places to the right. So I know I'm going to have a 1908, but since I have to move it 1 place to the right, I do have a missing space there. So that missing space will be replaced with a 0. So 190.8 as a percent would be 19,080%. Okay, now part C. Now here we got fractions, and we want to convert those fractions to a decimal. This is where we do multiply by 100. So if I take 5/6, multiply that by 100, and I'm going to put 100 as 100 over 1. So 5/6 times 100 over 1, when I know that 6 and 100 have a common factor of 2. So if I divide 2 into 6, that goes 3 times. And then 2 into 100 goes 50 times. So here, 50 times 100 will be 250. And 3 times 1 will be 3. Now, we have to do a little bit of division here. So we do 250 divided by 3. This will be as a mixed number, 83 1/3%. So 5/6 as a percent would be 83 1/3%. All right, now part D, 3/8 as a percent. Well, 3/8, we want to convert that to a percent. We multiply that by 100, and I'll put that 100 as 100/1. And now 8 and 100 has a common factor of 4. 4 goes into 8 2 times. 4 goes into 125 times. So 3 times 25 will be 75/2. And of course, if you do 75 divided by 2, we'll get 37.5%. And of course, you could write that as 37.5%. Because 1/2 as a decimal is 0.5. All right, part E. 5/8%. Well, 5/8, we need to change that to a percent. Well, 5/8 is a fraction, so let's change that to a percent by multiplying by 100. And 8 and 100 has a common factor of 4. 4 goes into 8 2 times, and 4 goes into 125 times. Here, 5 times 25 will be 125 divided by 2. And 125 divided by 2 will be 62.5%. And finally, part F is 3/5. And we want to change 3/5 to a percent. Well, let's multiply by 100/1. And here 5 goes into 100 1 times, 5 goes into, well, 5 goes into itself 1 times, but 5 goes into 120 times. And then 3 times 20 will be 60/1 times 1, which will be 1. So 60/1 will be 60, but here will be 60%. Okay, so that's how we convert decimals to percent and also convert fractions to percent. And with these, we can just multiply by 100. All right, on the next page, converting percents to decimals can be done by writing the percent as a fraction in the form of n/100, and then converting the fraction into a decimal. Okay, so in this case here, if I want to convert each of the following percents to a decimal, that can be done. All right, so in this case, it's like 34%. And I want to change 34% to a decimal. Well, I can take 34. And of course, as a decimal, we'll divide by 100 as opposed to multiplying by 100. Okay, now I'm doing this on the calculator. So do 34 divided by 100, you'll get this number, 0.34. The manual way of doing that would be probably to drop the percent sign, move this decimal point 2 places to the left, so that decimal will be in front of the 3. So it'll be 0.34 for 34%. Okay, now for this one, part B, we got 4/5%. Well, let's change 4/5 as a decimal. If I do 4 divided by 5, that would be 0.8 and 0.8%. And then from here, we drop the percent sign move this decimal point 1, 2 places to the left. So I know I'm going to have a 0 in front. So that means 4/5% as a decimal would be 0.008. Okay. Now part C, we got 16 2/3%. 16 2/3%. Well, let's do this. Bring up the 16 point, and then I'm going to do 2/3 as a decimal by doing 2 divided by 3. Now, when I do 2 divided by 3, this might be hard to see, but this is what I get. 0.666666 repeating. So it'll be 16.6 with a bar to indicate that the 6 repeats. And then percent. And now to change that to a decimal, we drop the percent sign, move this over 2 places to the left. So the decimal point will be in front of the 1 this time. So this will be 0.166. And it will have the bar on top to indicate that that 6 repeats. And part D is 5/6%. 5/6%. Now in this case, I'm going to change 5/6 to a decimal by doing, in this case, 5 divided by 6. And when I do 5 divided by 6, this is where I get 0.8333, as you can see, repeats. So here we go, 5 divided by 6. Here, the 3 repeats. So this will be starting off as 0.83. And of course, it repeats. I'll put a bar on top, only the 3 repeats, and then the percent sign. And then next, we change this to a decimal by dropping the percent sign and moving it 2 places to the left. So I know I need a 0 in front. So 5/6% as a decimal will be 0.0083 with that bar on top to indicate that the 3 repeats. Okay. So that's how we convert from percents to decimals. All right, now let's try this. Some of the spaces on the chart below have been filled in. So here you're going to fill out the rest of the chart completely. Okay, so now 10%. And we want to change that to a decimal. In this case here, we drop the percent sign, move the decimal point 2 places to the left. So 10% will be 0.10 or 0.1. And then as a fraction, in this case here, for 10%, since the percent means per 100, I'll do 10 times 1/100. And that will be 10 over 100. But we can reduce 10 over 100 by dividing the numerator and the denominator by 10. So you'll end up with 1/10 as a fraction. Right, next, 36%. Well, 36%, here we drop the percent sign, move that decimal point 2 places to the left. So the decimal point will be in front of the 3. This will be 0.36. And as a fraction, 36% means this. Take the 36 and it will be over 100. And then we can reduce 36 over 100 by dividing the numerator and the denominator by, let's say, 4. 4 goes into 36 9 times, and 4 goes into 125 times. So 36% as a fraction would be 9/25. All right, now we got 3/8, and I want to convert that to a decimal and a percent. Let's start converting that to a decimal. If I do 3 divided by 8, that would be 0.375. That's your decimal. And then change 0.375 to a percent by taking that decimal point, moving it 2 places to the right. So the decimal point would be behind the 7. So it'd be 37.5%. Okay. Now 0.5, that's a decimal. Let's change it to a percent and then change it to a fraction. Well, for the 0.5, we need to move the decimal point 2 places to the right and add a 0. So that means 0.5 would be 50%. And then as a fraction, well, 50% means 50 over 100. So 50%, that's the number over 100 because percent means n over 100. And then 50 over 100, we can reduce by dividing the numerator and the denominator by 50. So 50 goes into itself 1 time, 50 goes to 100 2 times. So as a fraction, 50% is 1/2. Okay. All right, 64% as a decimal and as a fraction. Well, for the 64%, excuse me, for 64%, we drop the percent sign, move that decimal point 2 places to the left. So it's in front of the 6, so it'll be 0.64. And 64% means 64 over 100. And then we divide the numerator and the denominator by 4. Because we want that fraction in simplest form. So 4 goes to 64 16 times, 4 goes into 125 times. So 64% as a fraction would be 16/25. Okay, got a couple more of these. Let's try 2/3 as a percent and 2/3 as a decimal. All right. Well, for the 2/3, if I do 2 divided by 3, that would be that number, 0.666, and the 6 is going to be repeating. So this is how I'm going to write that, 0.666, and it's repeating like this, because I need enough 6s so I can move the decimal point 2 places to the right when I convert it to a percent. So here's our decimal, and I'll say here 0.6 repeating. But on here, I'm writing it like this because I need to change it to a percent so I can move the decimal point 2 places to the right. So it end up being 66.6 with a bar on top percent. Okay. And then 0.8 as a decimal, which is a decimal, but I want to change that to a percent. So I just simply move the decimal point 2 places to the right and add a 0. So it'd be 80%. And of course, 8/10 or 80%, I can say 80 over 100 and then divide the numerator and the denominator by 20. Since that's the largest number that goes into 80 and 20, 20 goes into 80 and 100, I should say. 20 goes into 80 4 times and 20 goes into 100 5 times. So 0.8 as a fraction would be 4/5. Okay. All right. So be familiar with those types of fractions here. We'll talk about more of that later in this video as well. Okay, now let's look at some applications that involve percents. Application problems that involve percents usually take on one of the following forms. One is finding the percent of a number. So you'll be given a percent of a number. You want to find out what that number is going to be. Okay, second form is finding what percent one number is of another. And then the third is finding a number when a percent of that number is known. Okay. So here's some examples on the next page. Here we're going to answer the following questions. And also we can write this as proportions, or we can write this as an equation and try to solve it. But in this case, let's do these in the form of a proportion. By setting up a proportion, it's much easier to do it that way, in my opinion. All right, in part A, what is 9% of 35? Let's set that up as a proportion. All right, 9% is going to be that number over 100. So it's going to be 9 over 100 for one ratio. Now for the second ratio, now you have to determine what goes in the numerator, which one will go in the denominator. The number that is after the word of always go in the denominator. This 35 is after the word of, so the 35 goes in the denominator. And it's going to be this number that we're looking for. So I'm going to let X be that missing number. So my proportion will be 9 over 100 is equal to X over 35. All right, so now let's cross multiply. This will be 100 times X, which is 100X, equaling to 9 times 35. That would be 315. So we got 100X is equal to 315. Now to solve for X, when multiplying by 100, we divide both sides of this equation by 100. So that means X is equal to 3.15 from 315 divided by 100. Okay. So that's part A. All right, now part B. 21 is what percent of 84? So this time we're finding what percent of 84 gives us 21. So the what percent is going to be that number, which I'm going to call X, over 100. Okay, so we're looking for what percent, which is that number over 100. And then that's equal to, again, whatever's after the word of goes in the denominator. Of 84, that means the 84 goes in the denominator. The 21 must go on top. And in this case, the number that's next to the word is or after the word is goes in the numerator. The number after the word of goes in the denominator. So this is our proportion. X over 100 is equal to 21 over 84. And now we can solve this proportion by cross multiplying. I'm going to do X times 84. That's 84X is equal to 100 times 21. 2100. So now I got 84X is equal to 2100. And to solve for X, I'm going to divide both sides by 84. So here I'm going to have 2100 divided by 84, which will give me 25. Now we're looking for what percent, so we must include the percent sign. So X is equal to 25%. All right, part C. 24 is 40% of what number? And I want to solve this. Well, let's set this up as a proportion. 40%, I can write that as 40 over 100 because of the definition that n percent is that n divided by 100. So 40%, using that definition, 40 over 100 is equal to, now, the 24 is next to the word is. That would be your numerator. This time we're looking for of what number? We're looking for the number that's after the word of. That must be x. That goes in the denominator. And now we can do 40 over 100 is equal to 24 over x. Let's cross multiply. 40 times x, 40x, equals 100 times 24, 2400. So we got 40 over x is equal to 2400. So now we divide both sides by 40. Divided both sides by 40. So this is 2400 divided by 40. That would give me 60. And do we need the percent sign? The answer there would be no, because we're looking for of what number, and that number that we're looking for is 60. Okay, and part D. What is 8% of 45? Well, the 8%, I can write that with a denominator of 100, so it'll be 8 over 100, and then that's going to be equal to, well, the number that's after the word of always go in the denominator, so that 45 is after the word of. And what is what we're looking for, that will be x. So it'll be 8 over 100 is equal to x over 45. And then we solve this proportion by cross multiplying. This will be 100 times x, which is 100x, equals x 8 times 45, which is 360. So we got 100x is equal to 360. And then to solve for x, we divide both sides by 100. That would mean x is equal to 3.6. Yeah, it'd be 3.6. Okay. So here I'm just using proportions as a method of solving these percent problems. You might use an equation to solve a percent problem, like what is would be x, and then is your equal sign, and then 0.09 for 9%. Of needs to multiply 35 and still come up with the same answer. Okay. I take a look at example 4. It says here, Mark has 68 boxes of candy to sell. He sold 50 of the boxes. How many did he sell? Okay. So here we're looking for this, if we want to write this as an equation. What is, excuse me, what is 50% of the 68 boxes of candy he had to sell? And he sold 50% of them. So 50% of 68. So the what can be the x, is will be your equal sign, 50%. As a decimal, keep in mind you drop the percent sign, move the decimal point 2 places to the left, so it'll be 0.50. Of needs to multiply 68. So here we can just do 0.50 times 68, which is 34. So he sold 34 boxes of candy. Okay. All right. In example 5, a survey reported that 25% of 1,800 employees favored a new insurance program. How many employees favored the new insurance program? Okay. So that means we're trying to find what is 25% of 1,800. What is 25% of 1,800? So what would be the X? The is the equal sign. 25% as a decimal would be 0.25. Means to multiply 1,800. So 25% or 0.25 times 1,800 would be 450. So that means here 450 employees favored the new insurance program. Okay. All right, here's another example. Bill got 49 correct answers on a 70-question test. What percent of the questions did he answer incorrectly? All right, he got 49 answers correct, but we're asked what percent of the questions he answered incorrectly. So let's find out how many incorrect answers he got on a 70-question test. So let's do 70 minus 49. And that will be actually 21. 70 minus 49 will be 21. So we got 21 questions incorrect. Okay, so now we're trying to find what percent of the 70 questions is the 21 incorrect answers. That's what we're trying to find. Now, if you want to, you can write this as a proportion if this works best for you. What percent would be, let's say, X over 100. And then that's equal to what's after the word of. What's after the word of goes in the denominator. The 70 goes in the denominator. What's after the word is or next to the word is goes in the numerator. So this is our proportion. X over 100 is equal to 21 over 70. And then we can cross multiply. 70 times X is 70X equals 100 times 21 will be 2100. And then to solve for X, we divide both sides by 70. And this will give us X is equal to, I do 2100 divided by 70, that would give us 30. And it'll be 30%. Okay. And if you notice, if you do it this way, using the method of solving, setting it up as a proportion, you'll see, if you're finding what percent, you don't need to move the decimal point 2 places to the right. Example 7. On a math test, Ben correctly answered 30 questions. These correct answers gave him a percent score of 40%. In total, how many questions were there on his math test? Okay. So in this case, we're not looking for a percent. We already know what that is. We're trying to find the number when a percent of that is known. Okay. So we know something here. 40% of what number? Because we're trying to find the total number of questions that was on Ben's math test is 30. Now, if you want to set this up as an equation, you can do that as well, which I'm going to do right here. 40%, if I change that to a decimal, that would be 0.40. The word of means to multiply. What number, which I'm going to let X be, what number, and the word is the equal sign, 30. So I got 0.40x is equal to 30. And then to solve for x, I'm going to divide both sides by 0.40. So that means x is equal to 30 divided by 0.40 will give me 75. So in other words, on his math test, there were 75 questions. But he correctly answered 30, and that gave him a percent of 40%. Okay. Excuse me. All right, take a look at this example here. This is another application of percents when we're trying to find the discount. Here we're trying to find the discount or the sale price. Okay. So let's take a look at this. A $210 suit is on sale for a 30% discount. What is the sale price of the suit? So here we're trying to find the sale price of the suit. So the first thing we need to do here is find out the amount of the discount and then take the amount of that discount subtracted from the original price to come up with our sale price. So let's start by finding the discount. Just the amount of that discount. Because the amount of the discount is this, 30% of $210. So now 30% as a decimal will be 0.30. The word of again means to multiply. And then 210, which is the original price. So if I do 0.30 times 210, I get 63. So that means the amount of that discount was $63. And from that, we can find out what the sale price is. So to find the sale price, that's going to be the original price of that suit minus its discount. So the sale price was the original price is $210 minus the amount of that discount is 63. So 210 minus 63 ends up being 147. So that means the sale price of that suit was $147. Okay. All right, here's another example. Here we got an airline ticket, costs $280 without the tax. If the tax rate is 9%, what is the total bill for the ticket? Okay, so now let's find out what the sales tax is. The sales tax amount. That's going to be the cost multiplied by the tax rate. So in other words, $280 times 9% as a decimal, 0.09. Okay, you can take 9%, take the 9, divide that by 100, you'll get 0.09. So if I take that 280 times 0.09, I would get 25.2, but I'm gonna add a 0 behind it because we're dealing with money amounts. So the sales tax is $25.20. And then for the total bill, is just going to be the cost of the ticket plus the sales tax. So the cost of that ticket was $280. The sales tax was $25.20. So 280 plus 25.20 will be $305.20. Okay, so the total bill for that plane ticket was $305.20. Okay, example 10. Gail received a 5% raise last year. If her salary is $19,110, what was her salary last year? Okay. So now, this might be a little bit tricky here to do this particular problem. So, you know what? Okay, let's do this. $19,110. That's a salary now. Let's multiply that by the 5%. Now, 5% as a decimal will be 0.05. Okay, so 19,110 times 0.05. And in fact, we might need to write that as an equation, which is this. I'm going to let X be last year's salary. X will be last year's salary. And that means there's last year's salary plus taking 5%, which will be 0.05% of last year's salary, equals $19,110. Okay, that would be the equation. Okay. You have to think about this for a moment. Last year's salary, she got 5% of that, and then that was added to last year's salary. Whatever that amount of the raise was added to last year's salary to get $19,110. So here we have to work backwards on that one. And now think of X as 1X. 1X plus 0.05X will be 1.05X. And that's equal to 19,110. And then we divide both sides by 1.05 to solve for X. So 19,110 divided by 1.05. Okay. Gives us $18,200. That was her salary last year, $18,200. Okay. Okay, here's another example. This one deals with finding the percent of increase or the percent of decrease. In this case, you're doing a sale. Address decreased in price from $80 to $60. What was the percent of decrease? Okay. So with this problem, we need to find the amount of the decrease. All right, the amount of the decrease is going to be this: the original price minus the discounted price. Original price minus the new, well, let's say new price. So the original price was $80 minus the new price, which is $60. So there was a decrease. Amount of decrease, 80 minus 60 will be 20. However, we want the percent of decrease. Percent of decrease. That means we take the $20, that's going to be the amount of the decrease. Now I'll just write this out. The amount of decrease divided by the original price. And we need to multiply that by 100%, because we need to, because only if you just do the amount of decrease divided by the original price, you're just going to get a decimal. You want a percent. So that's why you multiply by 100%. So in this case here, the amount of the decrease was $20 divided by the original price, which was $80, times 100%. So 20 divided by 80 would be 0.25. 0.25 times 100% will give us, and if you think about that, you can move the decimal point 2 places to the right, it will end up being 25%. So the percent of decrease for a dress was 25%. Okay. All right, next is this example. Let's say Mort bought his house in 2008 for $493,000. It was recently appraised at $302,000. What is the approximate percent of decrease in value? So just like we did in example 11, here we're going to first find the amount of decrease. Amount of decrease, which is, of course, the original price minus the new price. Okay. He bought the house in 2008 for $493,000. And it was recently appraised at $302,000. So we do have a decrease. By how much? So let's subtract 493,000 minus 302,000, and we will get $191,000. Okay. So now we need the percent of decrease. And that is, of course, the amount of that decrease. Divided by the original price times 100%. Now the amount of the decrease was 191,000. The original divided by the original price of 493,000 times 100%. So here 191,000 divided by 493,000 times 100. And in fact, let me go ahead and do this on this other calculator. You're going to get this decimal, and that's okay. You'll get that decimal. But I'm going to change that to a percent, so it'll be times 100. It would be, now to one decimal place, it'll be approximately 39%. Okay. So I'm going to say 38.7%, and it could be approximately 39%. And they did ask for the approximate percent of decrease in value. So it'll be to one decimal place, 38.7%, or to the nearest whole percent, 39%. Okay. All right, let's look at some mental math with percent. Mental math may be helpful when working with percents. And below we give two techniques. One would be using fraction equivalents. Knowing fraction equivalents for some percents can make some computations easy. So here's the table of percents and their fraction equivalents. Now, some of these examples that we did that I showed you in the video, we could have used mental math techniques. Okay, and I will show you a couple of examples that I've already did, which could have used a fraction equivalent, like in this case here, in example 4, when we did the number of boxes that Mark sold, where we were finding what is 50% of 68. Well, 50%, if you look at this, 50% as a fraction is 1/2. So I could have did 1/2 times 68. And this one is similar to it. In example 5, 25% of 1,800. Well, 25% is actually 1/4. So I could have did 1/4 of 1,800 and came up with my answer. So using fraction equivalents can help in doing problems, some of the percent problems. The second approach, or the second technique, is using a known percent. There are sometimes that we might not know a percent of something, but we know a close percent of it. Like in this case here, 55% of 62. We can break 55% up as 50% and 5%. We can find 50% of 62 and then find 5% of 62. Well, 50% is equivalent to 1/2. So we can do 1/2 of 62, which is 31. Now for 5%, we might not know what 5% is, but I know that 5% is 1/2 of 10%. So let's say 5% is 1/2 of 10% of 62. Okay, 10% of 62, that's 6.2. And then we take half of 6.2 will be 3.1. And then we add the 31 and the 3.1 together, we'll end up with 34.1 for 55% of 62. Okay. Also, estimation with percents. Estimation with percents can be used to determine whether answers are reasonable. Like if Laura wants to buy a blouse originally priced at $26.50, but now on sale at 40% off, she has $17 in her wallet and wonders if she has enough cash. How can she mentally find out? And we're going to ignore the sales tax. Okay, let's think about this. 40%, we got that. $26.50, let's try $25. It's easier to find 40% of $25 if we can do that. Okay, so 40%, well, 40%, you know what? Let's use 10% because I know 40% is 4 times 10%. So let's break that up. 4 times 10% of 25. And then 10% would be 0.10. 0.10 times 25 would be 0.25. And then multiply 4 times 0.25, you'll get 10. And that would be the amount of that discount. But if we subtract that $10 from the $26.50, you shall end up with $16.50. And this is her estimated cost of the blouse. And since the actual discount is greater than $10, that means that Laura will have enough to buy that blouse. Because what's going to happen here, she's going to pay less than $16.50 for that blouse. Okay. So that's pretty much how we can use estimation with percents. By, taking a percent of some nice number that we know how to get. All right, on the last page is computing interest. Simple interest means that the interest will only be computed on the principal for the stated time of the loan. And the formula for simple interest is this: I is equal to P times R times T. And this is where I, capital letter I, represents simple interest. Capital letter P represents the principal. Lowercase r represents the interest rate. And T represents the number of years, which is the time. Okay, and the time has to be in years. If it's in if it's something else like months or days, then for days you have to take that and divide that by 365. Or for months, you have to take that, the number of months divided by 12, because it has to be in years for this formula to work. And then the formula for the total amount, which is going to be A, to pay off the loan, would be this: the amount, total amount, equals to the principal plus interest, or P plus PRT, or we can write it like this, since the common factor is a P. So it'd be P times the quantity, 1 plus R times T. So now let's look at this last example in this video about just interest. Let's just say simple interest. Ernie Rolfe borrowed $6,450 at 2% annual simple interest. If exactly 1 year he was able to repay the loan without penalty, how much interest will he owe? So we're finding just the interest. So this is the formula that we use. I is equal to P times R times T. So here the principal is the amount that he borrowed was $6,450 times R, the interest rate is 2%. Now 2% as a decimal, you can think of this as 2 divided by 100. That would be 0.02. Interest rate has to be, when you compute it, has to be in the form of decimal. And we're talking about the time, which is 1 year later. So the T will be 1. And all we have to do there is just multiply 6,450 times 0.02 times 1. And we will end up with $129, which is all that we're looking for here. So the interest that he will owe if he pays that loan without penalty in 1 year. Okay, so that does conclude this video on section 7.4 dealing with percents. Do feel free to email me or contact me in any way if you have any questions about what's in this video.